Hello, my name is Daniel Grimmel, and I'm the Chief Data Scientist here at Business Science Solutions. Welcome to our Data Science in 5 Minutes video tutorials. These tutorials are meant to illustrate hands-on data concepts in under 5 minutes. Back in February, we wrote an article that was published on datacamp.com, which you see on the screen here, illustrating using the SuperLearner package in R. We'll post a link to that article so you can go read it. But today, we want to provide a live tutorial of the SuperLearner package that's demonstrated in that article. What the SuperLearner package does is it allows you to fit multiple machine learning models at one time and then finds the best way to weight the models and combine them into a weighted ensemble. We'll explore this a little bit towards the end of the tutorial. So to fit the SuperLearner, we're going to go ahead and open up R. We're going to create a new script, and then we're going to call some packages and load the data set that we're going to use to train the model. So if at any time you need to install a package that you don't have, you can just call install.packages with the package name. In this case, we're going to use mass for the Pima Indians data set. So let's go ahead and execute first couple commands here. We pre-coded to save some time. So you can see the variables that are present here in the Pima Indians data set. The prediction variable is going to be type, which is no or yes, and that represents if the subjects in the data set have diabetes or not. So another important thing is to code the x variable as a data frame and the y variable as numeric. And so to get the y variable to be numeric, we call as.numeric, and then we're going to subtract 1 from those. So we have 0, 1 encoding for our classification model that we're going to run here. So if we run that and we look at the box plot of the x variables, we see they need some scaling. So let's go ahead and scale them, take a look at the box plot. Okay, so now our variables are scaled, they're consistent, it'll help with our model performance, and we can go ahead and work on fitting the model. So now I've coded the rest of the script, which involves fitting the model as well as evaluating performance. So if we call library SuperLearner and then list wrappers, the list wrappers command is going to show us the prediction algorithms that are available to use inside SuperLearner. Now, SuperLearner does not install these packages for you. If you need to install a package, you need to install that package before you can actually use the method in the SuperLearner. It will call the method if you have it installed, but it will not install it for you. So for this tutorial, we're going to use Ranger, which is a random forest implementation. We're going to use XGBoost. We're going to use kernel support vector machines, or KSVM, and then we're going to use a Bayes GLM model. So to install these packages, you need the Ranger package, you need XGBoost, you need the kernel package, and then you need the ARM package. So if you haven't installed them, go ahead and install them now. Now, the SuperLearner model fit is a simple command. It's just SuperLearner. And then we're going to need to pass into that command, as you can see from the pop-up above this, you're going to need to pass in the Y data set, the X-train data frame, a new X if you're using something like k-nearest neighbors, which we're not. You're going to have to pass in the family, which can be Gaussian or binomial. The Gaussian is for numerical predictions or regression predictions, while the binomial is for a classification setting, and it implicitly supports 0, 1, yes or no type of encoding. And again, it has to be numeric. And then the SL.library argument allows you to list out the models that you want to fit. So it has to be in a list, so you have to wrap the models you want to use in the list command, and then you need to type in each of these methods as they appear in the list wrapper section. So you can see, close that with parentheses. So then we'll go ahead and execute up to this point so the model fits. And while we're doing that, again, I want to remind you, do not throw all models at the SuperLearner. We have a relatively small data set, but if you have a big data set, it actually could take quite a while to run. And if you throw all the models in there, it may never finish, or it may take a really, really long time. So now, if we look at the output of this, the output is very basic. We have the call that we used, we have the risk or the error, which is associated with each different model line, and then we have the weight of each model in the ensemble. So now what we can do is we can predict using this model. So we use predict.superlearner, call the model, and pass in our test data, which in this case is xtest. So then it'll give us 2 pieces in the data type, pred and library.predict. Pred is the overall probability output of the ensemble model. Library.predict actually shows you the probabilities associated with each model prediction. So we're going to use pred's $pred to actually encode these to 1 or 0, because if you look at them, they're actually not ones or zeros. Right now, they're probabilities. So we need to encode these to something that we can assess accuracy on. So we'll go ahead and do the if-else. If the pred is greater than 0.5, we'll put it at a 1. If not, we'll keep it at a 0. Now we can call caret and fit the confusion matrix to look at our accuracy of our model. Confusion matrix takes the predictions classification argument and then the y-test argument, which is our data that we're assessing performance on. So now if we call our CM, which is our confusion matrix, we'll see our accuracy is 0.7892. As a baseline, average accuracy on this data set is probably about 0.8. So 0.7892 without any tuning out of the box is a rather good performance on the model. And again, we get a boost from actually using ensemble learning here and using multiple methods to try to get a better accuracy in our outcome. And that's it. That's how you fit a model and predict using the SuperLearner package. Thanks for joining in, and see you next time.